What is the observable universe exactly? The area of the universe that can be seen and studied with telescopes and other tools is known as the observable universe. Light, the primary source of knowledge about the cosmos, can only move at a certain speed, hence this capacity is constrained. We are thus limited to seeing things and happenings that are a certain distance away from us. Things or events from the past that happened a long time ago are not visible to us immediately. The estimated observable universe's diameter is around 93 billion light-years, which is much more than the universe's estimated age of 13.8 billion years. The reason for this disparity is that as the cosmos has grown, once close objects have moved apart, making it take longer for light from those objects to reach us. All things considered, the visible universe is a huge and intriguing region, yet much remains unknown. Nonetheless, we are still learning more about the structure, composition, and history of the cosmos as well as its many phenomena thanks to observatories like NASA's James Webb Space Telescope and other scientific tools. Come along as we explore the novel structures in the farthest regions of the visible cosmos that the James Webb Space Telescope just made touch with. Subscribe to our channel if you want to be informed about news from the universe and its environs. Make sure to activate the notification bell and like this video. We would need to create means of transportation that would enable us to transcend space-time, such distortion engines or wormholes, in order to reach the extreme edges of the visible universe. Scientists have been debating these ideas for a long time. Some think they are either not feasible or go against the notion of traveling faster than light. Even if it were theoretically feasible, it would require machinery and technological advancements that are currently beyond our capabilities, and the viability of both faster-than-light travel and the application of advanced technology beyond the reach of current human intelligence is a topic of intense debate. According to the cosmic inflation hypothesis, the universe is at least 1023 times bigger overall than what can be seen. Since humans are unable to observe or measure the unobservable portion of the cosmos, this number is so enormous that it is unfathomable to the human mind. We are unable to determine with confidence what is outside of its boundaries. That does not preclude us from formulating hypotheses, however, using the data we have acquired from distant galaxies. This is the point at which NASA is crucial. Together with other space agencies and research organizations worldwide, NASA has significantly advanced our knowledge of the cosmos in a number of ways. NASA has previously published pictures of the very deep field captured by the Hubble Space Telescope before the James Webb Space Telescope went into service this year. But when the James Webb Space Telescope first appeared, it was used to see the farthest galaxy ever observed. These pictures showed that there were many galaxies gleaming in the far-off universe. It seems that the expansion of the universe causes light to stretch to redder wavelengths millions of years after the Big Bang, which happened around 13.8 billion years ago. This enables the James Webb Space Telescope to detect infrared radiation. The James Webb Space Telescope has seen a number of fields of far-off galaxies, enabling researchers to examine the rate at which stars created in the early cosmos. This has enabled us to witness galaxies developing in the early stages of the universe's existence. This information shows that there was a sizable number of galaxies in the early cosmos that were producing stars. These findings are really intriguing and provocative. Humans have long considered the notion that we are not alone in this enormous cosmos. But these new findings in the visible cosmos make us think that the unobservable portion of the universe must include millions of galaxies. This concept is very startling and inspires amazement and astonishment at the size of the universe. Does the cosmos contain any alien life? We are considering the potential of alien life because the evidence for life beyond Earth has never been stronger. Exoplanets are a large number of planets outside of our solar system that have been found using methods like the transit method and the radial velocity approach. Some of these exoplanets could be home to life and share traits with Earth. Another finding on the exoplanet WASP-96b, made possible by the James Webb Space Telescope, has confirmed this idea. The light spectrum of this planet, which lies outside of our solar system, shows the unexpected existence of water molecules. Furthermore, the spectrum displays faint indications of clouds and haze that were previously believed to be absent from a habitable planet. It is challenging to rule out the potential that there are extraterrestrial life beyond our planet given the livable habitats discovered elsewhere in the cosmos and the developments in the hunt for exoplanets. Even though we don't yet have solid evidence, findings and data point to the intriguing possibility that alien life exists. Given the size of the visible universe, what about the multiverse? Let me tell you, there are many possibilities. The multiverse, also referred to as the many worlds interpretation, is a theoretical concept in philosophy and physics that postulates the existence of multiple parallel universes or dimensions outside of our own. Quantum physics, which studies the behavior of tiny particles like atoms and subatomic particles, is the primary context for discussion of the multiverse. A quantum system may collapse into a single state as a result of observation, according to some interpretations of quantum mechanics. In contrast, the act of observation just splits the system into several states, each of which represents a distinct conclusion in the many worlds interpretation. It is crucial to remember that the concept of the multiverse is still very hypothetical and has not yet been shown to exist. As a result, it is challenging to say for sure if the idea is sound or not. The concept of the multiverse is appealing to some scientists and philosophers and may help explain certain events, while others doubt its viability. Since we don't know what exists outside of our world, the idea that there is a multiverse is nonetheless as plausible as the well-known Schrodinger's cat thought experiment or the nature of darkness. This idea sparks interest and contemplation, but it needs more study and proof to be validated. The topic of whether the phenomena known as dark flow exists is complicated and presents an interesting problem. In 2008, the idea of dark flow emerged as a potential explanation for the finding that, given the universe's matter distribution, certain galaxy clusters seem to move more quickly than would be predicted. According to the theory of dark flow, these clusters of galaxies could be pulled in a certain direction by dark matter or dark energy. But the presence of dark flow is still debatable and has not yet been acknowledged by the majority of scientists. According to some research, dark flow could really exist and be brought on by a gigantic structure in the universe that pulls galaxy clusters in. Other research, however, has not been able to validate the presence of dark flow and has suggested that other causes, such systematic mistakes in the identified ones, might be responsible for the apparent motion of galaxy clusters. We cannot say for sure if it exists outside of the visible cosmos, even though other research points to its potential existence. More investigation and proof are required to fully comprehend this fascinating event. Please share your thoughts in the comments section. Don't forget to subscribe and like, and I'll see you in the future video. The nature of dark matter and dark energy is one of cosmology's biggest mysteries. When combined, they comprise around 95% of the cosmos, with dark energy making up the remaining 68% and dark matter making up about 27%. We have not yet been able to directly identify any of these enigmatic components, despite their enormous effect on the structure and development of the universe. Our knowledge of the cosmos has a bright future since every new finding leads to new lines of research. The cosmos, in all its size and complexity, is evidence of the miracles of scientific investigation. The pursuit of understanding the cosmos will probably continue to influence human history for many generations to come, whether it is through deciphering the secrets of dark matter, finding evidence of extraterrestrial life, or investigating the very fabric of space-time itself. As we consider the future of space exploration, a natural question comes up. Will humanity ever reach beyond the observable universe? Will it ever be possible for humanity to go beyond of the visible universe? The concept is not only science fiction, even if it is presently much above our current technical capabilities. It embodies the insatiable human desire to discover and comprehend the unknown. Even with our newest spacecraft, it would now take tens of thousands of years to reach the closest star system, Alpha Centauri. Progress in propulsion energy production and maybe our comprehension of physics itself would be necessary to break out from the gravitational confines of our galaxy, much alone the observable universe. The use of warp drives is one possible remedy that is often explored in theoretical physics. Systems that bend spacetime to travel faster than light are hypothetical. It may be feasible to compress space in front of a ship and expand it behind it, producing a bubble that goes faster than light in relation to spectators outside, using ideas from Einstein's theory of general relativity, such as the occupier drive. However, there are still significant obstacles due to the enormous energy needs and unidentified physical consequences. Wormhole shortcuts across spacetime, which theoretically may link distant locations in the universe or even distinct worlds, represent another hypothetical option. Even if general relativity makes it possible for wormholes to exist, it is still just speculative that they will remain stable long enough for travel and not collapse under the pull of gravity. Our descendants could eventually transcend our present cosmic horizon, whether via these unusual methods or completely new physics that hasn't been found yet. Artificial intelligence's function in space exploration. Artificial intelligence (AI) is becoming a more and more important tool in our quest to comprehend the cosmos. These days, AI programs examine enormous telescope data sets, aid in interplanetary mission guidance, and even detect exoplanets by seeing minute patterns in light curves. For example, machine learning algorithms that sort through enormous volumes of data to find possible planets circling far-off stars have greatly assisted NASA's Kepler and TESS investigations. Similar to this, artificial intelligence (AI) methods are being used to anticipate cosmic events, model galaxy formation, and simulate the dispersion of dark matter. As we construct more sophisticated telescopes and space observatories, the amount of data will grow tremendously. Processing and interpreting all of this data would be practically impossible without artificial intelligence. AI may eventually let self-governing spacecraft that are traveling to far-flung parts of the solar system and beyond make choices in real time without the need for directives from Earth.